Anybody play Blueprints?
I don't think I have. What's it about?
It's a like roguelike puzzler. Won a bunch of awards last year. I just started playing it over the break. It's really good. I mean, it's like one of those really really complicated board games, except it's a video game. So like you don't have to manage 100 pieces and board configuration and all that kind of stuff. It's good. I like it a lot. As an old person, I like rogue type games because that just used to be games. Like you start, you see as far as you can get, and then it ends, and you have to start over. I mean, I really enjoy the Spider-Man games. I love all those, but I mean, that's sort of like the maximum. Like that game is so.
Have you played the Batman ones yet?
I played it a little bit. I mean, so yeah, like I was kind of away from gaming, and then came back, well into the Arkham Batman stuff.
Arkham is so good.
It's great. I mean, for me, as like a more of a Spider-Man person than a Batman person, it felt like Batman was just slow Spider-Man. So there's a little bit of that, but yeah, I mean, like I could see how we don't get to those Spider-Man games without them making those Batman games first. I mean, I guess I kind of wanted to try and play because that's all. Is it all Insomniac? Is that right? Like the Arkham games are that, or no? Like I can't remember. No, the developer of the Batman game, Rocksteady. Yeah. Like they're making that Wolverine one, but that may be too violent for my.
What did you say? What's too violent?
The trailer for the new Wolverine game.
Yeah, I.
Like I'm older now with children, and so my capacity for that kind of wanton video game violence is different than it used to be.
Yeah. One of these days, I'm gonna go through my Steam library. What's on your like backlog? Mostly platformers that I'm like. I just got. I had to play Silver Case. I kind of want to play that because it's Suda. Ugh. I really like this.
Silver Case?
Yeah, the Silver Case. That's what it's called. It's like
I
a
haven't seen that one yet.
visual novel, sort of.
Oh, okay.
It's made by Suda 51. He did Killer 7 and No More Heroes. So, and I like his the stories in his game. They're usually really outlandish.
Yeah, I mean we have an old Switch, and then we have PlayStation 5. The Astrobot game is just like top notch.
It's really good.
Yeah, like everything about it is super 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 well done. Um, that was a lot of fun.
There's another platformer I'm kind of excited for. It's like an indie one. I think it's The Big Catch. There's a demo on Steam, and it's crazy big. I put like 40 hours into the demo, and it's like open world too. And there's like 10 different levels in the demo, and you like go across the open world, and there's like even like a secret like ending you can get, like a secret level. Sounds cool. I haven't heard of it. It's really fun. Dude, the soundtrack sounds like Phantom Hourglass Zelda. Such a good soundtrack, and the visuals are like GameCube era, like PS2 era, and it has platforming sort of like Mario Sunshine. It's just really good. Sounds interesting. You can get a bit hard though sometimes.
Yeah, I downloaded Silksong. I was just sort of like, oh, this is fun, or like it's super pretty, but like in no world am I good enough to like complete this game in any sort of like reasonable amount of time. It seemed really hard for me.
What do you say it was again?
Silksong, the sequel to Hollow Knight.
I heard what you said. I was talking to him.
Oh, okay.
The Big Catch. Oh yeah. Thanks. Yeah, no problem. There's like the demo called the Tackle Box. supposed to come out like last year. I was so upset it didn't come out because they had to delay the game. I was like, no, the one thing I was looking forward to.
So did you watch the Super Bowl?
Yeah. It was a rough football game, but
I really just watched them for the commercials.
I was, my mom called me down to be there for the halftime event. I like the part where Bad Bunny says fuck Donald Trump. I like that part.
Before
I'm not even a big fan of Bad Bunny.
okay, sorry, mislabeled the stream, everybody. This is 287. I'll fix it later on my YouTube studio. So everyone there, yeah, this is the usual class. I just typed the wrong thing as I was opening up the stream. Cool. All right, let's keep going. Let's do this thing. Everybody got their notebooks ready over here? Yeah, and so we've made it a long way. Let's look at this, right? So smearing, the idea, right? What's the difference between a squash, a stretch, and a smear? I mean, these are not like overly precise technical terms, right? They all imply one thing, deformation. But in reaction to what? Squash and stretch, the way we've been doing it, they're sort of motivated either by some other object, right? And then for smearing, the connotation is that it's sort of motivated by velocity, not necessarily an impact with another object. Otherwise, you'd call that a squash or stretch. Regardless, this is all just kind of splitting hairs. The idea here is that we are deforming the shape in some way. And so this presents, in hand-drawn animation, I'll have you guys make a squash and stretch hand-drawn this week. This doesn't, if we're doing it in a typical frame-by-frame, drawing each frame style, this doesn't present a huge technical hurdle, right? We can just simply redraw the object squished according to the proportions that we want, right? That's pretty easy because we're not tied to the way the object looked in the previous frames in a technical way. We can just redraw it, fine. When we're doing it in 3D, where the object persists from frame to frame, and we're using the interpolation, we've been able to do the squash and stretching by manipulating the scale parameters, and that's worked in the instances that we did last week, right? By using this the scale. But that's not going to cover absolutely every type of deformation that you would want to make to a shape. And so the idea that we're going to deform this 3D shape is going to require different, approaches and strategies, technical strategies, in order to make that happen. Because if we watch this here, if I were to blow this up so that we can see it animate, yeah, the top one has squash and stretch, so does the middle one, sort of like different amounts of squash and stretch. The top one has a little bit more, stretch as it goes through there. And then the bottom, they're not impacted, they're not running into anything. They're just moving back and forth. And when they increase in velocity, we have one that is smearing across the screen and the other one is not. And so, yeah, is this frame here in the middle a stretch or a smear? Yeah, that's just like pedantic language stuff, right? We are deforming in the direction of the velocity, right? Okay, so with that in mind, right, that's what's going to make our approach to, this smearing part, the follow through, to some extent the exaggeration, although we've talked about exaggeration already, right? We created that continuum, which is essentially a continuum of exaggeration, right? Cartoon-like behavior is very exaggerated. That's what, it's used for comedic effect in many of those instances. And so all of these are going to require different approaches in order to do some sort of deformation. Right here, the deformation is kind of happening side to side, kind of jiggly. Over here, we're smearing in the direction that we're moving. Here, we're doing this extreme squash and stretch. So, yeah, let's look at some options here. One that we can look at is, do we want to use this, or let's start with the sphere. So I'm going to get rid of this one for now, Shift A. Part of the strategies here as well are going to be dependent on the shape that we're animating as well. So we can sort of take some simple approaches here at first and then go from there. So I set some things up here just to, a lot of you already have the Blender skills to understand this. This is a just plane that I'm using as a backdrop. I made sure I applied scale so that it's at 1, 1, 1. Remember, that's Control A scale. Or another good strategy, just Blender-wise, to take care of this is to not scale the object in object mode, right? So here I made a new cube. If I scale it like this, then it gets some sort of non-111 scale numbers, which I have to correct by going Control A scale. However, if I only scale the object in edit mode, right? So tab into edit, press S, and then tab back out, the object scale remains 111. And so that is just like a Blender strategy for not having to remember to apply scale. If you did it that way each time, it'd save you some steps. Anyways, this plane, I applied this checkerboard material. So under the materials here, I went to shader, the shading workflow. Here we are. And here, we'll talk more about this stuff later, but just the basic part of it, we have the shader, and then this is the material. Which if you make a new material, it's going to look like this and this. And then here, Shift A, again, is your friend. You can search for a couple standard textures, and so the checker texture is one of them. And then another, if you don't already have this add-on enabled, under Preferences, Add-ons, the Node Wrangler add-on and noise nodes, both of those are ones I always have enabled. Node Wrangler allows you to do this, which is change the projection of the texture. And so now you see that the checkerboard is distorted. If I select the checkerboard texture and go Control T like this, I get the mapping and the texture coordinate node. I'm not going to spend a lot of time talking about this now. We'll talk about it some later. But I have UV unwrapped this plane. You can do a very simple UV unwrapping. If you go to UV editing, select all of the faces, press U, and then go to Smart UV Project. This will unwrap the object. Is it making the world's best UV map? No, it's not, but it will work in many cases. Then back here into shading. And so how do we actually access the UV map? We need to get the coordinate space from the UV map and not the generated one. We'll go into what these are a little bit more later. A lot of you are already familiar with some of the texture space coordinate projections. And so again, I can get both of this, the texture coordinates and the mapping, by selecting this and pressing Control, right? If I delete these, as long as I have Node Wrangler installed, I select this one or press Control T. There they are. They both show up. And now I can go from here to UV to project things in the correct way. And so now you see that this looks like checkers. Able to project it well enough here. There's a little bit of seam in the middle, but there's that. So this is fine. The curved part here is part of the bevel modifier. And so this bevel is just making this curved cyclorama backdrop here Here it is without the modifier. Here it is with the modifier. There it is. Everything's together. And then back over here. Yeah. So I've got, you know, a light and the camera setup, just a different sort of setup than the, you know, 2D glow ball thing we've been doing. File, save as. This is going to become 287. This is going to become smear. Okay. And there we go. Okay. The other thing I did earlier is I went over here to defaults, save startup file, right? So I've done a bunch of stuff to configure this one. And if you do that, it'll make this whole setup what you'll see when you just press Control N to make a new Blender file, so that you don't have to like set stuff up over and over and over and over and over again. So that's another good time saver. You already know some of this stuff, just general Blender blending knowledge there. Yeah, okay. So any questions about that? I mean, if it's new to you, follow along with the clicks there. We'll dive into these topics in greater depth later on. If it's not new, you know, that's just sort of some things I did to set this up. Yeah.
Is that supposed to be mandatory, like the coloring or something?
Say that again?
Oh, is it mandatory for like the coloring or something?
Well, yeah, the managing the projection space in the material is necessary in order to get it to look like what you want.
I just forgot how to do it, that's all.
Yeah, yeah, like I mean, it was just the Control T, and that gives us that, right? This is just the checkerboard, you know, material there. Okay, and let's make, that was this part here, right? So once an object has material, if you say new material, there you go. Then if you come over to shading, this allows you to actually edit the material. This is what you have, right? So now if I want, this is a material that's on this ball, right? And so let's make this ball look a little bit more interesting. I have noise nodes installed, so I'll go Shift A noise, and then I'll grab, yeah, sure, dot noise. And I'll run that into base color. There we go, now I got some dots on there. You could change the color of these dots. I don't know, I don't like that. Let's do a different noise, search for noise, Shift A noise. How about Cranel noise? And then, let's go to Perlin noise. There we go. And this can go into here. You get some kind of noise there. Let's turn it up or down. And we can give this color if we want by going to a ramp, color ramp. So this goes into here, and this goes into color. Then you could pick other colors. Trying to find which part.
Oh, that part right there.
I'm in the shading workspace. Should be along the top up there.
No, I found it.
There we go. So with some generated UVs there, we can do a marble-like looking thing instead of a glow ball kind of thing. So I was just messing with the scale on the noise. This is a fun one to animate. You can see how the noise here generated by over the space. This looks cool. This is like the fundamental technique for, you know, doing the surface of water here. for, water animation. Yeah, but if you turn it down, you get that kind of marble look, and you can have different levels of detail on it. The other ones, yeah, we'll leave those alone for now. But make it a little bit shinier, maybe make it a little bit more metallic. There we go. I'm seeing the reflections here because I am in the shader edit mode, okay? The shader edit mode has something in there to reflect. If you're just in the regular mode, it'll look a little more boring. There's the shader edit mode. We'll get to the differences between those in a little bit. Okay, cool. That's in place. So let's come back over to layout. Okay. Okay, so let's set some keyframes here on this. And let's move it on the X again here. So like that smearing we were just talking about there with the object moving, right? The simplest instance of this is smearing in that direction. Again, I make sure that before I do anything, scale has been applied in case I change the scale on the ball, so that everything's where it needs to be. And you can see that, scaling in this direction is essentially smearing it. And so let's set up the keyframes first. So we'll go, here, and then we'll move across. This is a lot of frames. I'm going to dial it down to 96 frames so that things are a little bit snappier. There we go. Just sort of zooming in here. And we'll move across. And if we want to sort of reproducing that smear example, there we go. Doesn't look like the velocity is high enough to motivate a smear here, right? And so let's come into the graph editor view and motivate a smear, right? But what if I wanted to start at this time and end at that time? I need to make that stronger S. And so if I grab this handle and pull it out a bunch, and I grab this handle and I pull it out a bunch, I start to get that more pronounced S shape, right? And greater slope here equals what? Greater slope, meaning a stronger angle on the graph editor, is going to result in greater what, Lawson? Exactly. Right? That's why the stronger S-curve, because it creates this, it's going to take longer to get going, and then it's going to really get going, and then it's going to slow down over there, right? So this is an extreme ease. Right? The stronger S gives us that ease in and ease out. So now we have enough visual velocity to, motivate a smear. And so here, yeah, we want to block this out, right? At the highest velocity, we need to be smearing, but before that, we need to be undeformed. And so we need to set some scale keyframes here, right? So just like the squash and stretch, we want to start at 1, and then we get to a point where we are smearing in that direction. And so, but this time, instead of, stretching in the Z, because we're moving to the side, we're stretching in the X. This is all relative, right? It just, in this case, that's the orientation of the object. I'm going to put this in local. In this case, it's the same. And then, Alec, what do we want to do here and here? We smeared in this direction, but kind of push it in, right? Yeah. The term here is preserve volume, right? This is the balloon principle, or the inflatable ball syndrome, right? If you take a big, like one of those big inflatable balls, like the yoga balls, or those training balls, the ones that people are like bouncing on when they go to the gym. If you take one and you squeeze it like this in, the top is going to go up and the bottom is going to go down, right? Because the amount of air inside remains the same, and more or less the volume of the air remains the same. And so it's going to do this. And so we need to preserve the volume, right? Because otherwise it doesn't really look like a smear. It just looks like the object got bigger, and that doesn't really communicate the same thing. And so here, these need to get below 1. So I'll put them at like 0.8, 0.8. Right before, I was making a big deal about making sure that the amount of change numerically was the same in both directions. Yeah, like ultimately it's art. It needs to look right? So you want it to look like it's preserving volume, but does that mean it always has to be the exact same number as the delta change here? No, it doesn't. And so set those keyframes, and then we need to get back to undeformed, and so we need to come back to 1, 1, 1, enter, set those keyframes, and so now we have smeared. We just smeared this thing, and so now a lot of it is about figuring out the timing of the smear versus the velocity. And so going back to the dope sheet here, and unfurling in this direction, uncheck that, right? And so this, looking at what you have here, X location is this keyframe and this keyframe, and then these are the squashing. And so here, if we wanted to smear for less amount of time, this is one of those instances where I'm going to grab these, I'm going to put the playhead here, press S, and now I can smush these while maintaining this proportional distance between them. This is really, really handy to do, right? Because I've essentially blocked out the animation. I need to go from undeformed to deformed to undeformed. But now, you got to remember, when you press S down here, it's going to scale from the playhead, right? And so if I scale here, it'll smush in this direction or out there. So it's as if it's the origin, the cursor up here, or the anchor point, right? The cursor, the 3D cursor thing, I don't really use that. You'll see other Blender people use that 3D cursor a lot. It just doesn't click for me. But the idea of scaling from the anchor point, right? Remember all the trouble we went through for moving the anchor point to the bottom of the ball so that we could do the rotation, and so that when we squashed, we didn't squash, we didn't bring the bottom of the ball up, right? And have to then fix the anchor, anchor point placement is super important. Let me just say this again. Before you animate, consider the anchor point. This is period for all animating ever. Maybe not for hand-drawn stuff, because there's no anchor point there, right? You can just sort of draw it however you want. So again, you're trading things off there, right? You have this total freedom of just forming the frame however you want, but you also don't get any of the automatic tweening and all of the other stuff that comes along with computer-based interpolation there, right? And then remember, the anchor point in Blender is referred to as the origin. And when you're searching the documentation, you would search for this. This is why when I'm doing this, I try to tell you when a term is a general computer graphics term and when a term is a Blender piece of vocabulary. Because when you search the documentation, you want to use the Blender word. Otherwise, it's not going to come up in the documentation, right? So for those of you not familiar, Qt Blender documentation. I know a lot of you, when you have a problem, you immediately go to YouTube. Sometimes there's someone on YouTube who's made a tutorial that answers your exact question using your exact version of Blender, and life is good. Many times, that is not the case. And so looking at the Blender manual before going over there may be the way to go, right? Or at least coming over here and checking it out. Right. You can search the entire documentation and how the origin works with the mirror modifier, so on and so forth. Anyways, a lot of people just go directly to YouTube, and then, when it is perfectly addressing what it is that you want to do, great. When it doesn't, video is a great medium, right? There's a reason I'm doing it here. Like it's really, you can see the screen, but it's not very searchable, right? When you search on YouTube, YouTube is not searching, as far as I know, the transcript of the videos. It's just searching whatever people tagged and then whatever people set up as the title and description. And so think about that for a second. Think about all the knowledge that's contained in YouTube videos that is not exposed to searchability, to discovery. It's staggering when you think about that, right? Think about my video. This is why I created the tool I created for you guys, right? The thing that searches my transcripts on my videos, because that was a major hole in my pedagogy, in my teaching, right? We had these huge videos with this ton of information in there that wasn't super available. And so that was one of the ways that, I've made that work. Would it be better if YouTube searched the transcripts of everything? Yes. I'm sure there's a reason they're not doing that. I mean, just simply the scale is probably staggering, right? I don't even know what the statistic is. It used to be, how many hundreds of hours of YouTube video are uploaded every second or whatever, right? Like it's crazy. So anyway, yeah, the instruction booklet, check it out. Also, the right-click online manual. And so I'm looking at this, and down here I'm like, I have no idea what this does. Right-click on the parameter, online manual. It'll take you to that exact part of the manual. So that's also a super, that's the first thing I do, right? In terms of like, this thing isn't doing what I thought it did. And then I try to read the documentation to figure out like, what is it that they think they're doing? Now, I think the documentation is very good. There's definitely some instances where I found parts of the documentation that were not explanatory. And so there's that, right? Okay, cool. And so now I want to make sure I'm just deforming closer to the middle. There it goes. Okay, I've smeared. And in this relatively controlled instance, this worked out okay, right? Good. Let's go ahead and make some text here. Edit. And let's move this one around this way. There we go. Let's extrude this thing a little bit. Over. Here, this one. So a little design thing. Extruding text. Not too much. Okay. Unless you're doing some sort of very specific effect. If you start to really lay into the extrusion of the text here, for instance, you're just kind of making it less readable. And so this is one of my reoccurring design pieces of advice for you. I might put this on a separate page in my notebook. If you have type or text on screen or in your thing, why is it there? What do you want people to do? When you see text, what do you do? It's no, I don't need you to edit it. I just want you to, like, if I show you, you're reading it. I think it was kind of a trick question there, right? Like anytime you see text, you're just automatically reading it, right? Everybody, like, you can't even. The idea of like showing you text and having you not read it, right, is kind of bizarre, right? We just automatically read it. And so the idea that you would do anything to make it less readable, no, don't do that, right? We're putting it on screen there. We want it to be readable, and so we don't want to make it less readable. And one of the things that makes it less readable is certainly extruding it to an extreme amount. And so here, if I make this less here, here, like so. Part of the reason the extrusion makes it hard to read is because it kind of destroys the silhouette of the text. And so if we're doing three-dimensional text, that's important. Let's make a new material for this. I'm going to get rid of this one. There we go. Let's make it metallic. Kind of here. Kind of here. There we go. And let's scale it up. There we go. And then, of course, Control A, scale. There we go. Everybody, watch what happened right there, because that is super important. Okay. I got this text, and I want to put it behind the ball there, so I just moved it back there, and then I just jammed S, scaled it up, right? And then I pressed Control A, scale, and do it, you know, even if you don't totally understand this, what I'm about to show you reveals the importance of it. So try to pay attention to this one. If I apply scale here, watch the thickness. Why did it change? The object scale is relative, right? What have I told you you want your object scale to be? 1, 1, 1, right? 1 what? Another trick question, right? It's not any what's. It's relative, okay? It can be a big thing, and if that big thing is naturally supposed to be big, it's 1, 1, 1. It can be a tiny thing, and if that's the natural size of the small thing, that's 1, 1, 1 as well. So there is no metric here. It's not meters, it's not yards, it's not inches, it's relative, okay? But part of the reason this becomes such, and I'm making such a big deal out of it, and why it becomes such a problem, especially today we'll rig some stuff with some bones, okay? And then we're just opening the door to this being even more important, because if the scale in a rigged object where there's a hierarchy is off at some point, forget about it, right? It's going to be a mess, okay? This becomes even more critical. So why did it change size? It's because the extrude was in a fixed size, right? It was in meters, which is the Blender default, right? The Blender cube is by default 2 meters high. How big is a meter? Did we do this before? I think we did this before. No, like ballpark it. Show me, how big's a meter? This big or this big? Okay, yeah, that's close-ish, right? What is the American or imperial equivalent of a meter? Yeah, a yard, right? It's not the same. A yard is not exactly equal to a meter, but it's close-ish, okay? And so 3 feet is a yard, okay? You guys know how big a foot is. Foot is 12 inches, right? Everyone's got a pretty good mental idea of that. And so a meter is around 3 feet, okay? And so the default Blender cube, when we make it, we're just looking at it as this tiny thing on the screen. And so you probably think of it as like a 2-inch cube that you put on your desk, right? If you were to think about it in real life or whatever, right? But it's actually as big as I am, right? 2 meters, I'm 6'1", right? Is 6 feet, right? A little over 6 feet. And so there is actual scale in the Blender scene, and that's what it is. You can change all this. We will not change it right now, but like that's how big the things are. And so keep that in mind. The reason that it changed shape when I did the apply scale is because this was in a fixed size, and then it was being multiplied by this. And when those two things change their relationship to each other, then, because look at the extrude, 0.07 meters. Whereas the scale of something, notice there is no m up there. This is a relative measurement. It's just like a multiplier. You just multiply the number times something. Whereas this is an actual size. It's a specific 0.17 meters. This will play out again and again and again. And in a lot of ways, the whole semester is going to force you to understand this concept, right? You have to get this idea, right? So again, if I go back here, here it is, it's larger. I go Control A, scale to reset the scale, boom. Because that's the fixed size interacting with the relative scale, which is why we always want to have the relative scale be 1, right? Because 7 times 1 is 0.1 times 1 is 0 times 1 is 0, right? So doing math, when you multiply something by 1, is pretty easy, right? Just makes the rest of this much, 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 much easier. Yeah, Arlinka, I'll try to upload the output of all the animations. If not today, then maybe Wednesday. Arlinka asked if I could output the actual movies that I'm making. Okay, good. All right, we've got that. Now, let's continue our smear journey. There you go. One thing, something we're going to check out here is the appropriately named add-on entitled smear. So in this case, they nailed it with the title of the add-on. There's some Blender add-ons where it's like, the name of it, you just look at it and you're like, I don't know what this does. Who knows what this does, right? And then sometimes it's like, oh, wow, this is really useful. It just has a terrible name. In this case, they nailed it. Okay, so under edit, preferences, I believe it's under add-ons, is that right? Or maybe an extension. Nope, it is under extensions, smear, there it is. Smear in all capitals, install. Okay, and let's do that. So I'm gonna make a, in order to demonstrate this, let's use a cube starting the first time. And so there we go. And let's bring this up. Let's move this back. We'll move this one over here, kind of like this. There we go. Maybe move this forward a little bit. Okay. And now, okay, not Mark. I installed an add-on. I just installed a new extension or add-on. I want to try that out. Where most likely is the interface going to be? How do I get to it? Where are most of the add-ons? N. Thank you, Alec. Right? N brings up that drawer. Most of the add-ons are over here. Okay? That's where the interface is designed to be. That's not all of them. Some of them do other things, but like most of the time, that's what's happening. And so over here under smear, right? If you installed it correctly, now you got this menu right here, which was not there before, which allows us to do all the things. Okay, so in order to actually use this, it needs some motion first. And so let's again give this the same kind of motion, this cube I just made here. And so I'm gonna do that. I'm gonna save to make sure I've got everything. And let's select this, there we go. And then move this one. There we go. And there we go. And let's make sure we get some velocity in there, doing the same sort of thing. If you hold down shift while you're pulling the handle out, it makes it harder to move it up and down. You grab this. If you start moving it and then press control, it locks it. Well, it's snapping to the grid. And so that doesn't let you go up and down, because if we were to go up and down like this, So those of you who really know the graph editor, which principle of motion graphics is going to happen based on that thing right there? Anticipation, very good, right? Because this is the position that we were at. We want the other way first, and then we want this way, right? And so you can use the Bezier handles, as I discussed previously, to do this, right? The only issue is that you don't have a point here and you don't have a point there to sort of like exert more control over it, but it works, right? So now if we watched it, boom, there we go. Over here, I want some more, actually, let's just make this simpler. Here, and line this one up. There we go, like so, and zoom. Okay, great. We have excelled. Let's give this some color. There we go. And I also wanted to have some rounded corners, so I'm going to throw the bevel modifier on it and set this to 2. I usually always bevel in even numbers. That makes it easier to take care of later. I usually check harden normals and say shade smooth, and then let's make it, I like shiny things, so we'll make it a little bit shinier. There we go. Okay, cool. There we got a thing. Now that's happening. Okay, so let's check out the smear. I've got the cube selected, and over here under smear, there's different options here. Let's go with the first one here, elongate. And so, of course, it's going to throw me an error. Oh man, am I going to run into this? Yeah, so we're getting a Blender Python error. You can go to console. Or it's in the scripting. Scripting. What is this telling us? I was just using this all weekend and we were fine. Let's see here. What if I try to do the other thing? Ba-boop-ba-da. Let's try this again. See, this has frames here. And there we go. Yeah, so if you crash after you install an add-on, you have to reinstall it. I'm sure you guys have run into that. Cool, now I'm not getting the install button. Here we go, let's try this again. I mean, it's under the installed section, but it's not showing up over there. Man. I can't install it, and it's not showing up in the menu. Let's try this other thing. You guys clicking along with me, were you able to install it okay? Is anybody getting that same Python error? So did you get the error or no? Like when you click that button that says bake smears, does it give you an error or no?
Where's that? Where do you guys click on?
I don't think anything really happened.
I didn't.
Nothing happened, but you didn't get an error.
No.
Yeah, okay, yeah, that's what should happen.
I didn't do that yet.
Did you do the drag and drop version of it? 'Cause you could just,
No, I just did it from the menu there. Let me
yeah, 'cause if you go to like the site,
try that. That's a good idea.
you got the little feature where you can just drag and drop it in the actual Blender scene.
I'm a little bit confused though.
Hold on a second. It's confusing.
And what's that? What's that say? 'Cause it didn't say that for me.
Already installed.
No, I'm thinking helpful. So maybe you gotta uninstall it and reinstall it. Maybe some just.
I don't have I don't think I even have the uninstall button.
Maybe we'll do nothing with it.
Oh, there we go.
Okay. Do that one.
There we go. Okay. Are we back? Okay, now I'm going to save and close so that next time I open, it's there. And hopefully we can make heads or tails of this. Screencast keys is on. There we go. So now, yeah, no one else in class was getting that same error I got, so hopefully that's just my own issue. Yeah, now it's still there. There we go. If I were to give this thing some keyframes. We haven't done anything yet, so just sit tight. Hold on. We're just making sure it's not computer. That's always important.
I had that multiple times, like 2 semesters ago. That was happening.
There we go. Okay, so we are animating here, right? Like so. Let's again give it some more velocity. doing this thing. There we go. Let me make sure I got the chat up. There we go. And here we go. Control.
I think it was the level modified.
What's that?
I think it was the level modified because I tried with that and it gave me the same error.
Oh, okay. Interesting. All right. So yeah, we won't bevel here. You have it on? Okay. Well, all right. Well, the problem was the first part of using this thing is pressing this button. Okay. So this sort of the add-on's using some sort of data that it needs to calculate and save before you can do stuff. And so you need to press that. And so when you press that, nothing happens, but it then you should notice that these things become ungrayed out so that they're able to be used. Okay. And so here, there's sort of multiple options, right? And so let's go to the elongate option here. And so I'm going to turn that on. And if we look at this now, just hit space here, right? We're getting this, right? So a sort of typical sort of smear, right? This looks visually indistinguishable from kind of like what we were doing before, right? But it can get more interesting. So for instance, here, I'm going to put some fun rotation in the middle of this thing. And so I'm going to go ahead and set some keyframes here. And then when we're moving around, I'm going to, let's say, this. So been watching a lot of Olympics where a lot of snowboarders and skiers are flying. We're just going to do a 360, not a 1280 or whatever else those people are doing. And let's bake again. There we go. So now let's get some more time in that keyframe. Come back to the dope sheet. Unfold. Of course, these were unfolded by default. There's probably a thing for that. Okay, so anytime I change the actual animation here, you need to have it recalculate what it's got going on there. And let's actually give this some more space. There we go. And so now we'll see that even without that, now it's stretching, but also taking into account the actual rotation of the object, which is great. The main things here are smear length, right? So 0 and hit play. You'll see that it's just the regular animation, nothing changing. As I turn this up in the middle, I think you'll see this happen live. Yeah, you'll see it start to elongate. Now, the interesting thing here is that depending on what you're doing, it does smear into the future, which when you think about it is pretty crazy, right? It's like, kind of like stretching into the direction that's going. Right, it's kind of confusing because like physically that's not, when would we want to use this? Why would this be there? This is going to increase anthropomorphization, the humanization, the giving of life to inanimate objects, right? That's what anthropomorphizing is. Like taking this, and this is what, remember what's the name of the Disney book that defines the 12 principles of animation that I linked to in the very first week of class? Check your notes. Or look at the first week on Canvas. Yes, the illusion of life, right? Anthropomorphization is the illusion of life, right? We're taking inanimate things and giving them life. This is a thing an animator can do, right? In terms of making inanimate things animate. And so this, right, this is not a feature of inanimate things. They don't know where they're going, and so they can't, deform in the direction of their movement for the most part. Right. But here, it is, right? So this, having it be 1 by default strikes me as like maybe not what I would pick as the default, but anyways. 0 here. And so now it's more like I think you would imagine starting here. Like it's like the trail of it being stretched behind. And so the smear length, how far it stretches behind there. Now, it is deforming the existing geometry. And so that's going to make a difference. I'm going to say unbake smears. I'm going to save. I'm going to grab this here and then subdivide this with the tool. Subdivide, subdivide, subdivide. And then tab back out here and bake smears again. And activate. And so now look at that. Look at it. There we go. Now we're getting a much more naturalistic stretching and trail from what's happening. Actually, back to 0. And so now it's just a trail of what we have there. And so this, you know, as I've done this different ways in different programs, and as I was refamiliarizing myself with this add-on over the weekend, like this is impressive. It's fun that this works. But those of you who've already taken 3D modeling, a single face cannot be what? Mark, you've taken the 3D modeling class, right?
Cannot be what?
That is my question for you.
Single face cannot be, I don't know, more than one face?
I mean, yeah, that's a pretty
Or like,
obtuse answer to the
I
question.
don't know, like, are you talking about the normals?
Can't be bent, right?
Yes.
In order to create curvature, we need to,
Have multiple faces.
right, and usually we achieve that technically by subdividing, right? And so the rules of 3D modeling still apply here. We're focusing on animation, but we're animating 3D objects, right? Which is why that when I did it to the unsubdivided cube, it looked better, but especially when I spun it, it started to look pretty janky, right? Very meh, as Lawson correctly described. Now that we have subdivided the cube and told it to recalculate smears, now I get much more of what we would imagine happening here with the cube, right? Because remember, by default, when we just make the default cube, how many faces does the default cube have? Yes, 6. That's it, right? Now we have many more when we subdivided it, and so there's more faces here to be deformed along. Does that make sense for everybody? Why this looks better? Ed, does it make sense for you? Why this one looks curvier and better than the other one? Ed? You think so? Edward, right? No. Do I have your name wrong?
No, you got it right.
Okay, all right. Do you have the bevel deformer on there? Try that. That may have been my problem before. I'm not going to try to reproduce it. Did you? So it's gone?
Yeah, it immediately fixed.
Okay, so for right now, everybody, I'll research this and see if there, I mean, because obviously we'd want that to happen, but no bevel on smear. It's a limiter for right now, but you know, whatever. So here, right, we're able to smear in this direction. We have this subdivision happening, right? There we go. So for instance, if I were to, we can do this right here. We can tab out to edit mode, I think this is a good, if everybody understands this principle, this will be good, right? So if I shift D this thing, the actual object, Control C, Control V, there we go. Whoops, I got a bunch of things selected. I don't want all that stuff. Just this. Control C, Control V. Why is it doing that? Just this. I just want this thing. Probably because I have this. Let's say unbake. There we go. Now can I shift D it? Yes. So unbake to proceed. So here in this cube, I'm going to unsubdivide, which I think is an option here under mesh. It's somewhere. Does it show up if I right click? Subdivide, unsubdivide. There we go. right? So when you subdivide and you just get quads, you can run an unsubdivide command. The unsubdivide command is not always available, right? If you have a triangle, you can't unsubdivide that in the same sort of easy way. Okay, so now we've got two of them, and they both do this, right? And so, but this one looks like that, and this one looks like that. And so now we will bake smears on this one. We will bake smears on this one, and turn on the elongation. Turn on the elongation, and we can see the difference here, right? We get curvature happening in the smear direction, and over here we don't, right? Especially so if we turn down smear down to 0 on both, and then I'm going to turn the length up to, I don't know, 2 on both, and we can see exactly what's happening here. So like this is deforming the existing geometry. I'm going to shade auto smooth here. If I shade smooth, it's just going to kind of like obliterate the corners, which is not, if it's just a regular cube, it's not what you want to do. Auto smooth will keep the sharp corners, but then smooth along there. Over here, it makes no difference. The shade smoothing is not going to do anything because there's no curvature happening between here and here. It's one face, right? If we look at this one, there it is. Look at this one, right? So when I tab into edit mode, see how there's a massive difference between this and this? That's because this is, you know, the underlying geometry, and the other one is not. But pretty cool, huh? That it's doing this, right? Deforming it in the direction that you're moving. Yeah, we ran into that one hiccup there, but hopefully that's better. The other thing here, okay, so we have that. And again, this one is curvy because it is subdivided. That's what I want everyone to write down in their notes and learn here, right? In order to do this, we are subdividing there. And then also, just on a technical note, if you want to duplicate something with a smear on it, unbake first. It's a little, you know, it's a little annoying, but in general, this add-on is doing a bunch here, which is nice. Great. And so here, for instance, we're going to duplicate this one again. Grab this one here. I'm going to unbake. There we go. And bring this one back. And again, Shift D this. Y, let's just move it forward. There we go. And so over here with this one, we've got that in place. And now we'll bake here. We'll turn this on. You can have noise, which kind of gives it this wobbly trail. And so if you turn on noise scale, you can see that this is doing just kind of like a noise deform kind of thing for what's happening. And then that'll go away there, which is a cool effect perhaps in the middle. You can play with the amount that the noise is deforming it here. Right, so the closer you are to 0, sort of the bigger the noise waves are. And if you dial it up, they kind of get smaller. There's a point at which you won't see much of a difference because they're just deforming the existing vertices. And so the waves will get smaller than the space in between the existing vertices there. At 0, let's put this at 2. There we go. And so now you'll see that I get the trail happening, but the trail has this nice little like wobble to it there. And so we can turn this. There we go. Right, as if it's breaking up there at the end. There we go. Let's bake this one again here. Or a way to set up a thing there, but let's just keep it. There we go. So there is a bit of a limit to, here we're getting that faceting. I'm going to right click and say shade auto smooth. Oh, that was already on, so that's fine. If we wanted more detail in the noise, Like if I wanted there to be more detail here, what would I have to do to the underlying geometry? Alec? Yep, exactly. Right, and so as a matter of safety here, I'm going to unbake and then grab this one, tab into edit mode, right click and subdivide. Remember, every time we subdivide, I'm doing a lot of subdividing here, but you need to keep in mind the face count here, right? Every time I subdivide, Jose, when I subdivide, do I get twice as many faces or more than that? How many? Every time I subdivide, it's like multiplying by what number? Ed, do you know?
It doubles each side, right?
Exactly.
This is a bad time to look at sides right now. I want to say it's like 12 times or more.
4, right? We have one face. We subdivide this face by drawing a line here and by drawing a line here. And so one face turns into 1, 2, 3, 4. Okay? So keep that in mind. Every time you right click and say subdivide, you're quadrupling the number of faces here. So just be conservative. How much subdivision do we want? Just enough to make whatever it is happen that we want to have happen, right? What you don't want to do is end up with things that look like this. There we go. Right, you can see how I've posed this thing already, right? In that,
It looks like it's being shredded.
right. Well, the part of the problem here is that there's a terrible reaction happening between the subdivision and I have an unbaked. There we go. And so now if I rebake, yeah, it's going to be too much, right? And so, anyways, right click, unsubdivide. Let's see if we can get back. There we go. And then bake. Let's see, am I getting the same Python error now? There we go. Right, and so you can really create like quite a long tail for some of this stuff. Right? And especially when I've turned up the subdivisions there, you can see how this noise on the existing thing, especially if I were to dial it down a little bit closer, right? So this, I think, is much more artistically interesting than anytime you subdivide and then you start distorting the subdivisions and we start seeing like this jagged mess of geometry, like unless you're doing like a very specific sort of like glitchy sort of artistic thing, I find that less, usable. Here, turning the noise scale down towards 0 allows us to get a much more curvy, organic deformation. And so now, whoosh.
Do you use the Python thing? Or
What's that?
you use a different thing?
I changed the noise scale.
Oh, because it's not showing up where
Yeah, none of this shows up until you click the activate elongated. After you've baked, the first thing you have to do, no matter what, is bake smears, then click activate.
I'm trying to find it. I don't know where it is.
Did you get smear installed yet?
I did not get that installed.
Okay, that's the part where you're missing. You got to get the add-on properly installed. Let's turn this down.
Issue with the bevel thing.
What's that?
It was just that if you apply the bevel, it works fine, but since it wasn't applied, it caused the Python error.
Yeah. So it's the bevel deformer that's doing it, right? It's not the actual beveled geometry, right? So this is a problem of like, all of this stuff is adjustable here, right? So this is kind of like, they could have made this a deformer, right? The fact that it's over here in this menu is kind of arbitrary, right? It's, something that's happening over the geometry. And so when you have this thing, all of this is running on code. This is all instructions, right? Which is why we can dial it up and down. The bevel deformer the bevel modifier is running on code, right? It does a procedural beveling. And sometimes when you stack this thing and this thing with each other, for whatever reasons, they don't play well together, right? And so this was one of those instances. Yeah. Yeah. So that applying the modifier fixes most of those problems all the time, right? Because then you just turn it into actual geometry that you can use to calculate stuff. But there's some instances in which we don't want to apply the modifier so that we can still adjust the thing later. And so that only solves so many of the problems in that instance. Okay, so super cool, right? I mean, yeah, I was really impressed. So that's that activated elongated. Let's go ahead and save and keep going here. So I'm going to take this one.
We just continue as a save as, or just save as a, I know it just changes differently.
Well, I mean, I have the automatic saving on, so it's, creating the incremental saving. Like sometimes when I hit a point where I know I want to archive that version, I'll hit save incremental. But, here I'll just say save. But here I'm going to unbake this one and again duplicate it. In fact, let me give myself a couple of them. So again, Shift D, Y, move this over, Shift D, Y. There we go. I need some more runway for this tab into here. Grab this edge, make sure I'm edge mode. Let's move this forward to give myself some more floor. See how that stretches it? It's because this needs to be re-UV unwrapped. So grab all faces, press U.
If you do by angle, it's good for that type of thing.
Yeah. All right, good. I'm back. So now I've got these things. Let's tab back here, and let's look at the other ones. So here, we're going to go ahead and bake smears and look at motion lines. Right, so if you say activate lines and play this one, line length, I'll start turning this up. This one's kind of interesting in that it creates these just sort of trails here. And so let's turn it up even more. And there's the lines probability, I think, is the amount of lines. So if we start turning that up, there we go. Right, so see what's happening there? Instead of deforming the existing geometry, it's adding these points and then these lines. Again, by default, it has future lines, which, again, I don't see how it's reaching in that direction? If you take the future 0, now that seems much more artistically useful in that we have like this trail that happens behind it. So not exactly a smear, but like a stylistic kind of thing. Yeah, the radius of the lines themselves. So if these are longer, you get this kind of thing. That's too fat, clearly. Let's see if that cleans it up a little bit. And yeah, the responsiveness of this add-on I also was impressed with in terms of the, how I can dial these things up in real time and see the result as long as I'm using a reasonable render situation. Right, so what is actually happening when it says bake smears? Why do we have to hit that button? It's calculating information about the velocity of the object, right? Like, because we know the keyframes know, where the object is every frame, but the keyframes don't, when we look at the graph, we can see the velocity because we're seeing the keyframe position over time, but we're not storing that information anywhere, and now you can't do that. You can also give the lines their own material. Let's see, can I do that? I don't know why all these other ones showed up here. I'm gonna make another new material. There we go. Yeah, so another interesting smear-ish kind of thing. And finally over here, let's look at the last one, multiple in-betweens. And so this is more of like a, what I would refer to as a brute force version of this. And so if I say bake smears here and then activate multiples, this, if you look at it, this is another style of smearing, right? And so those of you familiar with the echo effect in After Effects, this is more akin to that, where we're creating the smearing by just simply, this is more like motion blur. The way motion blur is implemented often, in that we're just rendering the object as it is in the current frame, and then you're also seeing the object in the positions it was in the previous frames, right? And so, and in this case, future. So 0 there, past multiples, I'll turn this up. And then future, past displacement, there we go. I can turn that back, past multiples. And so we can see a different sort of effect there, right? It ends up giving you this very gridish kind of look in the case of the cube, but if the object was not as angular as the cube, that would not be the case here. And then here, the opacity factor, yeah, I didn't seem to be able to get that to do anything. Maybe that only works in cycles or something. So a different kind of thing, right? When you look at it and you know what's going on here from an animator standpoint, it makes a lot of sense. But it's just, you know, it's not, what happened the first time is that over here, elongated in-betweens, this is actually deforming the existing geometry. Over here, the motion lines, that's pretty self-explanatory. You know, it's drawing the trails. And then here, the multiple in-betweens, it's just sort of creating duplicate past versions. This is kind of like what happens with motion blur, or at least motion blur calculation. Yeah. Again, all of them have this default where they're reaching into the future as well, the stretch part of it. And yeah, I mean, in this case, I don't think that really works, but in other cases, perhaps. Especially during the high velocity parts of it, if I started turning this up. And here, with the number of duplicates, again, this seems to be fairly performant, at least with these squares. Then you know, you could dial this up to the point where it looks pretty smooth. But if you were to get to this point, where we have this, and it looks, you know, like really smooth there, you'd probably be better off deforming the existing geometry, right? This is really if you want that, because look how many extra objects we've created per frame. 52, right? It's not, it seems to play back okay for this one example, but that's probably not a great, right? Yeah, a little bit. Let's save this. All right, let's label these. Do I have the text from the other one? No. Apply scale. There we go. And a little bit more depth. Okay. This is going to be no smear. And there we go. Let's bring this one up. Let's shift D, Y. There we go. And this is, we'll call this one low geo smear. Right? Not enough topology, which is why we get that kind of look there. I feel like these need to be a little bit smaller. S, Control A, there we go. S, Control A. There we go. And then over here, let's Shift D, Y, this one. And so this one will be the subdivided smear. Sub D with the, sub D smear. And we'll just leave it at that. Over here, Shift D, Y, we'll call this one trail smear. And then over here, Shift D, Y. This one is going to be duplicate smear. And let's move all of these up a little bit. There you go. Bless you. Yep. So if we want to put the same material on all of these, Control L, link materials, there we go. And let's frame this up. Control Alt 0, there we go. That's not a very good angle. How about here? Control Alt 0, that's better. Come into the camera. Maybe adjust some of the focal length here. Be a little bit more zoomed in. So camera, focal length, maybe right about there. See how useful this could be here? Super useful. This idea that we're able to stick to the transform animations, but then engage in this stylized smearing in a bunch of different ways, I think is pretty useful. And having it actually, calculate the velocity of all the different vertices and then be able to use that to smear all of the existing objects here. Super great. Super great plugin. Okay, very, very useful. Let's move on to our follow through, right? So here, let's do a couple different versions of this one as per usual. If we look at Fabio says he likes the trail smear. They're like, it's very useful. I thought it was great. That bevel thing is a little disconcerting as to which modifiers it would work with or not work with. I have to do a little bit more thorough testing there, but we're close. Okay, cool. Okay, now follow through. So looking at our example here once again, over here and over here, right? So now we have follow through, this jumping and then wobbling back and forth here. And then in addition to the wobbling, there's some pre-wobble squash and stretch over there to some extent. But as it comes to a halt, part of it continues on and comes back. So we did a little bit of this previously with the anticipation, where we did some of the rotation for that one happening. Let's look and do several different levels of this, right? Again, the principles are the guiding artistic principles, right? These things, we want to exhibit these to varying degrees depending on what kind of style we choose, because they're effective ways of communicating not only the composition of the object, but anthropomorphizing the object. But when it actually comes down to using them in the program, we have to use different strategies because of what we just talked about. Whether in hand-drawn, we can just sort of draw it differently. Here, you have to have some different strategies for doing that. Okay, let's make another new one here and look at that. So here, let's look at this way and come in. So follow through here requires a little bit more prep, right? And so if you remember, when we did the anticipation, where did we move the anchor point to for the cube? In order to have the cube get ready, roll and fall back, and then go forward. Yeah, over here, right? This is where we had to move the anchor point to. So it makes sense. You're like, okay, well, if that's the case, we're going to do this here on this one. Probably makes sense. I can put it exactly there by turning on snap, and then hitting G and going into origins first over here, like so. Why can I not see origins? Oh, because I'm in edit mode. Origins, G, there we go. Snap it over there. Okay. So this, in terms of the, turn this off. This would get us, if we're not going to hop up and down yet, like the one in the example. We're just going to move across the screen. And so in terms of anticipation and follow through, this gives us the anticipation. But check this out. When we get to the end of it, right? Over here, when the cube is here, what are we going to want the cube to do? We're going to want the cube to go this way, right? And rotate around this axis. And so now we have one of the fundamental animation problems: double, anchor, point. Right, this can be a problem. Okay, in this case, we can sort of make this happen with using an additional parent object, right? So this is the simplest way to go about this, because it would be great if you could say, if there was like a plus version here, and just say like, give me a second origin, right? Because in this simple example, that makes sense. You're like, oh, I need to rotate this way, I need to rotate that way. However, that's not like a technical limitation. Like Blender just can't figure it out. If you start to think about that, if you take that further You're like, okay, well, I have these 2 anchor points. And then, okay, well, what happens to the rotation parameters? Well, one is the rotation parameters for one is, like, as it moves through space, which one are we rotating around? This becomes a conceptual problem. Okay, I'll go into more detail about this on Wednesday. This is what's referred to as the gimbal problem, where when you rotate, the order of rotation puts you in different final locations. So I'll demonstrate this later. It's a huge sidestep, and I just want to get through this part for right now. But we'll talk about that on Wednesday. It's not something that's intuitively obvious when you're just starting off here, but as things go on, it's the reason for a lot of complexity here. Okay, so what we're going to do, we've got this anchor point where we want it, and we need to have like kind of a functional second anchor point over there. And so in that case, I'm going to Shift A and create an empty, right? And so this, in Cinema 4D, these are just called nulls. In After Effects, they're just called nulls. It's just an axis, okay? Just another empty axis. There's no geometry associated with it. It's just an axis, and you can use it, to define a point in space, and you can use it for hierarchies, which is what we are interested in, because we're interested in building these more complex hierarchies out of multiple parts, and so we're going to be interfacing with this often here. Great, and so in terms of the kind here, I'm just going to go plain axis. Okay, and so by default, here it is. I'm going to call this cube parent. There we go. And so now this rotates here, and then cube parent, you see if I rotate it, it does nothing right now. Why does the cube parent not affect the cube? Yeah, I haven't parented it, right? Over here, they are both on the same level of the hierarchy, okay? And so the way I like to set this up, we've done this, do we do this before? You can use the Control P. What I like to do is hold down Shift and drag the child underneath the parent. That is more of a visual. Hold down Shift, click, and if you drag it over and let go, now you're like, oh no, what happened to the cube? If you unfold, you see that now we have established the hierarchy. The cube parent is the parent of the cube, okay? The other thing you can do is you can shift click on the parent and Control P and say object. And so that also does it, but I don't like doing it that way. I just like dragging it over here because I think it's easier to assemble the hierarchy that way. Okay, but before I do that, actually, I just undid it. I'm going to take the cube parent and move it to where I want the other anchor point to be, right? Because I want an anchor point here and I want an anchor point there, right? And so now I'll take the cube and drag it underneath. And so now we've got a situation where I can do this, and when I come back down to 0, if I grab the cube parent, I can do that and rotate along that other axis over there, right? So it's not going to, this doesn't solve absolutely every way that this would work, but in this instance, it'll work fine, right? And so, yeah, let's do this. So we will first animate across, and because we're going to animate across, we want to animate the top of the hierarchy. Like if this goes for characters to some extent as well, right? You have, when we get to a full character, like a biped human character hierarchy, it's many, 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 many parts, right? But when you actually move it, you're like, I want my character to be in the corner. You go to the top of the hierarchy, and that's where you change the transform, the position, scale, and rotation to move the character over to the corner. Then you do all of the individual rotations and everything like that. But again, here, you want to move this cube like we have the other cubes across this space. And so we're going to animate the top of the hierarchy. Hierarchy. When we get to characters, this is referred to as the root, right? This kind of, you're moving the root of the character to a different location. In a game engine, this is the thing that's actually moving around the scene. All of the other animation the character is doing lines up with that, but it's the root that's, like actually, this is where Pac-Man is at this moment, right? Okay, great. So let's animate that here. Again, I got too many. Just need 96, I think. There we go. And let's zoom in a little bit. Let's move this thing. So again, the parent. And so up until now, when we've been animating stuff, I've just been actually, I think I need to be moving in the X direction. So I'm going to need to change this a little bit. I'm going to unparent by shift dragging up to the top. That undoes it. Let's fix this location. There we go. And now reparent it again. There we go. And so this is here. This is here. There we go. I wanted mine on the X. When I was doing it before, I did it on the Y. Regardless, the direction that you're looking at it, this corner and this corner. And over here, that's there. Okay, turn off the snapping. One is there, the other one is there. Doesn't look exactly lined up. Because I had the snapping on. There we go. I'm just messing around, demonstrating this stuff and knocking everything off kilter. I'm just going to create cube parent again. Do I have something else turned on? Snapping? No, no. Oh, origin's off. Yeah, you can't move the origin. An anchor point does not, an empty does not have an origin. Its location is its origin. There's no separation between the object and the origin. I had this on while I was trying to move this object, and that's not good. Okay, so there we go. This is cube parent. There we go. And this is cube. There we go. Take cube, shift drag underneath here. There we go. Make sure cube is in the collection. This is a really irritating thing in Blender, is that you can be outside of the collection but still be the child of another object, which just ends up looking confusing. I don't know. There's not a lot of instances in which I want to do that. There we go. I've established the correct hierarchy. If I click here, that's in one corner. Good. If I click here, that's in the other corner. This is the actual origin of this object, and this is the origin of that object. Cool. Okay, and so let's animate the top one here on the X. And so let's back out here and look at this. Right about here. I'm going to keyframe that, and then move us in this direction, keyframe there, and again give us some of that velocity. Yeah, you can't hold. This is a weird one from a button standpoint. You have to start dragging, then hold down control. If you hold down control and start, it won't let you click on it for some reason, and so that's a little bit weird. Okay, so there we go. I kind of want to start faster, and so let's say like that. Cool. Okay, and so now we want that anticipation here on this side, and so we're going to need to do the cube. We want to rotate around this point, and so at this point we want to be coming down here, and so we want to be rotating on, yeah, on our X there. So I'm going to set a keyframe here, back up a little bit, rotate up, there we go, back up some more, and rotate down. All right, and so we go up. I didn't set the row. There we go. Set it. So boom. So this rotation sets us up. It doesn't really give us enough velocity into there. We need to see all of it, so let's bring it all out here. And so I can't see it because it's on a separate object. I can do this, and now we should be able to see both of them there on this chart at the same time. So again, being able to manage only visible. In this case, we have multiple objects. So being able to see them both at the same time is super useful here and here. And yeah, we want to, here, with the block is slamming down via rotation, right? So what is forcing the block down? Yeah, the force that's rotating it down. What other natural thing is propelling it towards the ground? Gravity. What does this curvature here mean? That we are slowing down as we get closer. And so we need to correct that, just like the bouncing ball. We want to slam down here. All right, that's good. But now we're sort of slowly getting going, and I want that to be a more direct takeoff. There we go. And these are pretty slow here. So let's go ahead and I think we want a little bit more time. Again, we want to see everything. And so I might take these and move them out a little bit. So if we wind up for a long time and then slam down. Right? So less time coming down, more time winding up. Moving this over. Closer. Even faster here for the wind down. There we go. Maybe even closer. Remember, the closer I get these, the more velocity that slam down to the ground has. There we go. That's pretty good. All right, so it feels like that's motivating that slam down to the ground. Now, on the other end, here's where we get our follow through. We're easing into this last location. In this case, we want it to seem like we're hitting a thing, right? In fact, we'll put a thing there, right? Let's do it. Tab out here, Shift A. Let's put a tiny cube there. And so I'll move this over, and let's look at it to line it up correctly. There we go. Scale this down. Move it over. Maybe even more. Yeah, kind of like that. Kind of like a bumper that we're going to hit. Let's make sure it's right at the end. Right there. So it's got to be right there. There we go. And then Control A, scale. There we go. And so now, boom. Let's go ahead and make sure we hit that with a little bit more velocity. So we come back to our graph editor here, come to our X location, right? And so we're easing into that a little bit too much. We need to hit that with some more velocity here. So I am decreasing the amount of ease into that. There we go. A little bit less even. If I want it to happen faster, take this and move it to the left. So we're just using less time there. There we go. There we go. That's probably enough. And so now when we hit the bumper, we want to rotate this way. This is our follow through, right? Sort of motivated by this object. And so now, right, we're not rotating here, we're rotating here, right? The top one, because this is anchor point is over here where we need it. And so now we need, should be Y rotation in this case. And so here, set a keyframe and then quickly sort of rotate over. And we don't want to go past, because then this would sort of insinuate that you're going to spin over, right? We want to kind of go just past it there, like this, and then eventually get back to, there we go. And there we go, and keyframe. Great. And so here, again, the same thing. We don't want to ease into this. This just looks like the bounce, because this is motivated by gravity. It's quick at first, then it kind of hangs, and then we want to slam down again. And so slamming down means that the bottom of this is not decelerating. It wants to yeah. We're not going fast enough, I think, to motivate that at this point. So we need, how do we make the cube go faster? All of this needs to move this way on the timeline, right? That means it's all happening in less time. It'll be faster. So here, back to dope sheet, grab all of this, move it this way a bunch, and there we go. And we need to actually, let's see, even less. And we need to not ease into that last frame as much. So here we go. Yeah, so Winter Olympics, right? I'm watching it. Curling. You guys know what curling is? Yeah, giant. I don't even know how heavy are those stones? Like,
I heard the stones are pretty heavy, and you have to like make sure like the ice is not rough in order to like.
yeah. You're scraping the ice and everything. But how heavy are curling stones? I'm gonna say 50 pounds. Yeah, not bad. They're not the same. 42 pounds. Okay. I mean, you're not lifting them up, right? So here, right, we usually go for this S-shaped thing, but we need to start fast, and then we need to sort of maintain speed when we slam into it. And so we're doing less curvature there. There we go. And again, this is one where maybe it's a little bit less symmetrical, right? And that it takes more time there. And then here, how long do we hang? And then how fast do we slam down there? Right, and so, boom. Yeah, and so again, I hope one of the things you're learning here is how much different things can feel just nudging stuff. Especially for as long as we're doing like 4 seconds of animation. Pushing things a couple frames one way or the other can really change the way it feels. There we go. Kind of want more velocity on that initial takeoff. So back here. Even greater. And I feel like the timing is a little weird here. Yeah. See how there's 1 frame of delay between the thing slamming down and taking off? Watch. If I take this one and move it back one frame. Now, yeah, feels different. Right, because before we were seeing it like an exaggerated version of this. See how it doesn't feel like they're connected at that point? It like slams down, poof, then it goes. Not the same as backing it up 4 frames, right? So 4/24ths of a second. Now it feels like, you know, it's motivated by the rotation there. Okay, and so this, let's refer to this as rotational follow-through. Right. The idea that part of the object is stopped and another part of the object continues on. In this case, we manifest that just by using position and rotation. But what if we want to have multiple parts of the same object go through like this? Okay. And then additionally, this is also one of our chances to solve the double anchor point, which can be, you know, an issue when you start to think about this. Not, yeah, I don't know. I'm not a physicist, but not, you know, unrelated to the 3-body problem situation, where it's sort of the order of operations for what we're calculating starts to matter. Let's save this one. Save as. This is follow through. Principles of motion graphics. Follow through. There we go. Great. So we got some smearing. We got some. This is follow through. Let's do some more follow through here. Where it'd be great to follow through in a different way. Where we're not rotating, but actually deforming, right? Like the one in the example, right? We kind of start going and the body actually deforms and then deforms in the other direction. So here, we can start to do this. We're going to need some bones, right? What do the bones do? You'll see most of you get introduced to this topic by seeing bipeds and their whole armature, right? The armature is just the name for the entire skeletal system, and the Blender uses the word armature, that fill out the entire shape of like a biped animated character, right? But that's a big complicated version of it. At the core, the bone is a transform, right? So just like that empty we just made, it's just a point in space that has influence over vertices. So if we were to move individual vertices, we can grab them and move them. In this case, we have influence, meaning that it can have a varying degree of strength. So each bone has a certain weight over a vertex. And this weight is usually a normalized value between 0 and 1. And so if the weight is 0, when the bone moves, the vertex will not move. If it's 1, when the bone moves, the vertex will match the bone. And if it's in between, it means that the vertex will move half as much, if it's 0.5, as the bone. This is what the weighting is, right? And yeah, this is the core of the idea. Everything else is built upon this. The fact that the bone has a size and whatnot starts to matter in other instances, but here it's this idea that we have something to work with. Okay, so let's start assembling such a thing. we're going to use a cylinder here. And so let's, save this. And then I'm going to shift a cylinder. While I've made it, I'm going to look over here. I'm going to go into wireframe mode so we can look at this. And Mark, related to the other question I asked you today, why will this cylinder not be great for deforming?
For deform? Well,
Based on this wireframe information
from this wireframe information.
that I've presented to you right now on screen.
Oh, it's because the circles at the top, they don't have like a lot of like inner loops or like circles inside.
Okay, there's not enough subdivision, right?
If you're bending the outer part of the cylinder, then it's fine. But if you compress it like this way, like you need loops around
Yes.
this way, and then you need loops in the circle, the side.
We need more sub D in both directions here,
Yes.
right? And so right now, we don't have enough loops in this direction, right?
Yes.
Because remember when we did the cube with the smear, right? That was part of our learning process there, was that when it was unsubdivided, it didn't curve in the direction of the deformation, right? Same thing here. So by the default, the cylinder will have probably too many rotational subdivisions. We could get away with less than this. It usually defaults to 32, but it has no subdivisions vertically, right? And so if I were to tab into here and just, I want to, let's say I want to bend this cylinder like this, okay? Not using bones or anything fancy. I'm just going to try and do it with, the move tool, right? So I'll grab this top face and I'll sort of do this and then do this. See how it's not bending? It's just kinda, yes, Slinky is bendier, but like here, there's nothing for me to grab to make the actual rounding happening here, right? And so, before we start rigging anything, you need to make sure your geometry that you're going to rig with a bone is actually suitable for animating with the form, right? The smear add-on was deforming the geometries. This is why we ran into this here. Here, we're going to deform the geometry again, but there needs to be geometry to deform. So if we tab back out, get rid of that one, Shift A again to a cylinder, and I'm going to make it a little bit thinner. I'm going to bring it down to 12 going around. That'll be enough. And then under the depth here, kind of like that. And this is not going to give me a subdivision here. We're going to need to do it manually. And so I'll go into face mode. Control R is our loop cut. And once I press Control R, if you use the scroll wheel, you can dial in multiple cuts. And so how many do I want? Just enough, right? You guys are getting it, right? And so doing this is not solving my problem. It's making more problems. In this case, it's a fairly low poly thing. Getting it to where they look like squares is probably a good rule of thumb, right? And so now you click with the loop cut tool. Now it lets you slide those up and down. We do not want to offset them. We just want to kind of put them in the middle. And so I click again. So if you haven't used the loop cut tool before, there's some getting used to in terms of muscle memory. Control R, scroll wheel. I'm not holding down Control R. I just press Control R and let go. Now as I move the scroll wheel up and down, that gets more or less cuts. Then you click once to slide, and then you click again to cut. So it seems like a lot of stuff at the beginning, but you'll get used to it. Or if you just Control R and cut, then you can use this menu to sort of dial in the number of cuts if you don't want to deal with the scroll wheel part of it. And so now if I just click out, I've got this, right? So if I select this object, there we go. That's about the amount of geometry that we want to have right now for this. I'm going to turn off the visibility on these things so we can just focus on this cylinder for now and come back over to here. And then I'll go ahead, shade auto smooth. That'll give me a thing here. If I turn that up a little bit, you'll see it'll go from faceted to smooth, but still have a clean top. Great. Okay, so now we've got this. I'm going to go ahead and make sure to Alt-G this back to the middle of the world so it makes it a little bit easier to deal with. I'm going to press the slash key to just sort of focus on this for a second. That makes it a little bit easier to see. Okay, now we need to create an armature for this. And so here we're going to do something very simple. We're just going to have two bones, one here and then one here. And so the process, what you want to write down here is create armature object. That's in object mode. Then with the armature selected, you go into edit mode. In edit mode, you essentially build the armature, right? So in our case, it'll be very simple today. We'll just make two bones. And the main tool that we're going to use is we're going to just extrude one bone from another. And the shortcut for that is E. Then once you're done with that, you will go back to object mode. And there we need the armature will be a completely separate object at that point. Have nothing to do with the cylinder. What we need to do, this is called binding. We need to make the bones control the mesh. That's called binding. Bind them from one to the other. And so in Blender, you parent the mesh to the armature. And so what you want to see at the end of the day is this. At the top of the hierarchy will be the armature. And then below that will be the mesh. The opposite will not work. If the mesh is the parent of the armature, that's not going to do it for you. Okay? And then here, when you press, what is the shortcut for parenting, if you had to guess? Control P, good guess. However, when you press Control P, you're going to get a menu of options here. And so what we want is automatic weights. Okay, those are those weights I talked about before. And this is going to essentially determine how far a vertex is from the bone and then scale that bone's influence based on that distance, which we'll get to more of this later. Obviously, I don't want my thumb bone changing what my cheek is doing, right? That's going to be weird. In such the same thing here. We want the bones to control the mesh close to the bone. When you have many more bones, this becomes a much more complicated issue, and that's when you have to weight paint the object to sort of control this. Yeah, okay. I'll give everybody a second. Write this down, right? So 1, create armature object. 2, build the armature in edit mode. 3, parent the mesh to the armature using the automatic weights. This will get you in the ballpark so that now when you move the bones, the mesh will deform, which is what we're after here. And then why are we doing this? So that we can create follow through, right? Rather than animating all of the individual vertices for this cylinder that we created, we're going to be able to animate two bones, and that'll end up being a simpler situation than animating individual vertices. There's ways to animate vertices, but usually, yeah, this is the preferred way to do this, right? Also, this system of using bones to control vertices is like a fundamental part of 3D files, right? So the core part of it, having a bone deform vertices, works in every 3D program, right? Unreal, Unity, everything else. And so if just that core part, if you export that, that comes along for the ride, right? That it's part of the core. Usually when we send something from one program to another, we use an FBX format, and that's part of the thing that can be stored in an FBX format, is the bones and the weights of the bones and the animation of the bones. Okay. Yeah, let me turn this on to random so that we can see that. Okay, great. And so now I've got this selected. Let's just do a little housekeeping before. This is the cylinder. Make sure everything is reset. Make sure they're at 111. I'm going to move the origin point down to the bottom for now, and then turn that off. And yeah, okay, we are good. Make sure I'm not missing what everything is saying. Okay, great. Now let's make the armature object. I'm going to save and then Shift A, and then armature. Boom. Okay, there we go. We get this, and you'll see absolutely nothing happen over here because it's just like the big container object for all of the bones. There's no bones yet here. We have to make them here. And let's go ahead and actually, we can probably save ourselves a step here, actually. I think it's because I don't get that other option there because I don't have Rigify installed. We're not going to use any Rigify today, but I'm going to install it. Preferences, add-ons. I think it's under add-ons. Rig. Where is it? There we go. Rigify. And
Are they also, is that where like this mirror is also?
yeah, it's another add-on. Exactly. Now Shift A, armature. Yeah, single bone. Yeah, so we'll just use that. We're not using any of the other fancy stuff. Single bone. And so that gives us this, and that is way over there. I'm going to press Alt-G, sort of move that back to the world. Okay, so that saves you a step. We've got armature. Yeah, if you have Shift A, or Tab, Shift A, armature. If you don't have single bone, you need to install Rigify. Okay, it just gives you this shortcut, which is useful. It does a bunch of other stuff, which we'll get to later. Okay, so now we're in the armature. We are in object mode. So far, so good. I'm going to move this down so it's there, and then I'm going to tab into edit mode. Okay, so now I'm in edit mode here, and we can select different parts of the bone, right? You have to make sure the armature is selected when you tab into edit. And so if I select the top here of this and press E, that can extrude out a second bone. And we're just going to do 2 bones for now. Okay, good. All right, we got 2 bones, and just without doing anything here, you'll see that if this one moves around, the other one's there. They're connected, okay? Just leave it as is. We're pretty good. Okay, so I've got an armature, and then I've got the cylinder, and I'm going to call this, we'll just leave it as cylinder for now. Okay, so now select armature, shift select cylinder, control P, or other way around. Select mesh, select bones, control P. Yep, I always forget that. Select mesh, then select bones. This is another thing where Blender, really cares about what order you select things in. You have to get that right. Then control P, and then parent with automatic weights. This seems like a lot of work right now. Once you go through this a few times, it gets a little bit easier. Okay. Right, so now, again, in object mode, select mesh, then select bones, then control P. Now I get, this is how I knew I messed it up before, is because I didn't get these options down here. And so here I can say with automatic weights, boom. And again, absolutely nothing happens. Great. Except what happened to my cylinder? Where is it? It's under the armature, right? The armature is now the parent of the cylinder. Boom, boom, right? If you unfold the armature, you'll see that there's a bone. And if you unfold here, you'll see that there's two bones. Bone, bone. Okay, those are the two ones that we made. This is the first one. The one labeled O1 is the second one. Good. Okay, and so now object mode is for, creating the object. Edit mode is for building the structure of the skeleton. Okay, it's where if you need to add a finger, you do that in edit mode. And then our new mode here that we have not previously used is pose mode. Pose is where we actually animate the bones. Okay, so up until now we've been animating exclusively in object mode, right? Using the transform almost completely. Now we can go into pose mode to animate the bones or see their influence on the object. Make sense? Good. Right, and so now up here, pose mode allows us to do this. We can click on different bones, and at first you can sort of test this out. So if I rotate this, everything comes along. That's good. If I come up here and rotate this one, ta-da! Right? This seems like a lot of work for this effect right here. But again, like I'm taking a lot of time to explain everything along the way. Right? Once you do this a couple times, armature, bones, blah. Right? And so now you'll see what's happening. So up here, these vertices are weighted, 1 to this bone. And so as this bone moves, these move completely, as if it's the total parent of those vertices. Over here, at the joint, this is where, this one doesn't move completely because it's got a little bit of influence from this one and a little bit of influence from that one, right? And so you can rotate, and then over here, these can rotate individually. And so the bones themselves, over here, if we look at the bones, you're used to coming over here to the object tab. To get our transform information for the bones, it's actually going to be in the bone tab over here, which rotated it too much. Let's go back. There we go. And select this one. There we go. And this is true not only in 2D as I was explaining it, but like here you can see in 3D. This is also working because we have a mesh here. Okay. The plan for animating here is that the root bone, which I guess we'll rename here, that's the one at the bottom, we're going to do the transform here, right? So just like I said before, the root is the thing you use to actually move the thing around. And so this means that we will animate transform position, rather, to be more exact. For the other bones, in this case just one, we'll call it the top bone for lack of a better name, we will only be animating rotation, right? Because it stays attached to the other one, and that will primarily be animating the rotation of the bone. So let's just get this blocked out, and then we'll call it a day and fine-tune this on Wednesday. So I'm going to come back to here, press slash to get back to our normal view of things, and grab the, let's get back up to object mode and just sort of put this up here. There we go. And then let's select the armature and go back to pose mode. And yeah, and so let's rename this. This is going to become root. And this is going to become top. There we go. So we know which is which. And so now, for instance, let's just block this out real quick. I've got, where's my timeline? There we go. And so here, we want to be animating the location of this. So here, there we go. And then we can move forward to here. There we go. Right, and so we get that happening. And now, for instance, before this happens, if we come up to the top bone here, figure out which way we're going to rotate. In this case, it's going to be the Y, I believe. Nope. Where are we at? Top bone. There we go. Nope. Or Z. There we go. Based on, oh, this is still in global. I want it local. There we go. Now you can see that the Z is what we'd want, right? So you're rotating around that axis right there. Having this be in local most of the time is the better call here, right? And so now here, for instance, Z keyframe back. There we go. There we go. And here we go. 0. And so now we can deform and hit the limit here. And then this can keyframe, and then keyframe. And we'll clean up this later, but we've got anticipation. Yeah, we got to clean up the keyframes, but we've got the basic stuff in place there. I'm going to say right click. Let's go back to object mode. There we go. Cool. But the main thing to get through there is just the super simple rigging, right? Yeah, you can see how, like, certainly there's less moving parts, literally, to animate these two bones than to sort of wrangle all of the vertices for this object in order to deform it like this, right? And you can see how this allows us to do a whole bunch of stuff that we weren't able to do with just the scale, like we were in the bouncing balls. Okay, great. And looking forward to seeing everybody's stuff on Wednesday, and then we'll continue with this introduction using bones and everything else. Okay.